All right, folks, so as we jump into Unit 6, Congruent and Similar Triangles, we're going to start off with our Pythagorean theorem. Now, when we're using our Pythagorean theorem, or in general when we're working with a right triangle, we want to label it according to convention. So that means that each vertex or angle for any triangle is labeled with a capital letter. That means your labels can be as such. We need the vertexes to be capital letters. We'll also see that our right angle itself will be labeled with the C itself. Now, in a right triangle, the hypotenuse is always the side opposite to the right angle. So our hypotenuse will always be labeled with a lowercase c. There we are, right across from the right angle, lowercase c. So you'll see opposite to one another is the same letter, just labeled either lowercase or uppercase. Each side of the triangle is labeled with the lowercase letter. Now, the other two sides, we call those the legs, are the two remaining sides. Those can be labeled with a lowercase b and a lowercase, a. Now, our Pythagorean theorem itself, and you should have covered this a little bit in grade 9. Our Pythagorean theorem itself, it's used only with right-angled triangles, and that's because we can kind of use that to, we can remind ourselves of this by recognizing we need a right angle in order to find our hypotenuse. If there's no right angle, there's no hypotenuse. If there's no hypotenuse, there's no Pythagorean theorem. But here we do have a right angle, therefore we have a hypotenuse, therefore our Pythagorean theorem will work. So our Pythagorean theorem is used to determine the side lengths of right angle triangles. So if we know two of them, we can come up with a third side length from the Pythagorean theorem. It's the relationship between the two legs, side lengths of the legs, and the side length of the hypotenuse itself. The formula needs to be rearranged, perhaps, depending on whether you're solving for the hypotenuse or for a leg. And that means depending on whether the unknown that you're looking for is the hypotenuse, if you know the two legs but you don't know the hypotenuse, or if you know one of the legs and you know the hypotenuse but you don't know the other leg. And finally, at the very end, our Pythagorean theorem is given by a squared plus b squared equals c squared. So that means that in order, if we're solving for an unknown at the very end, then we'll need to make sure we're taking the square root of whatever we're working with. Otherwise, we'll end up with an inflated value for a side length. So let's try it out. We'll use our Pythagorean theorem to determine the length of the unknown side, whether that's the hypotenuse or whether that's a leg. We'll round our answer at the very end. Now, right off the start, we need to recognize, okay, so we see the right angle here, we go opposite to the right angle, and this is our hypotenuse, right? It's labeled a C, that's fantastic. They did a great job labeling it for us. So here's our hypotenuse that we're looking for. Now, if that's the case, if that's a C, then we need to label the others A and B. It does not matter which is labeled which, as long as C is your hypotenuse. So here let's call 16 centimeters A and 12 centimeters B. And then we'll use our Pythagorean theorem. Our Pythagorean theorem, A squared plus B squared equals C squared. Fantastic. Now we substitute in the values that we know. So A equals 16. That is 16 squared. B equals 12. That is 12 squared. And C here is an unknown. We do not know the value of it, so we're just going to leave it as C squared. And then we're working forward, and we can evaluate here 16 times 16. That's 16 squared here. We'll simplify it. That's 256. 12 squared is 144. And again, C squared, the right-hand side, we're leaving as is. Then we can add these up. So 256 plus 144. We're working with here 400 right on the dot. 400 equals C squared. So now we need to remember that last piece. That's great that we found the value for C squared, but we're not looking for C squared. We're looking for the value for C. So we can square root both sides to get rid of this square, leaving us on the right side with just a C, and on the left side the square root of 400. That's 20. So in this case, C equals 20 centimeters. Fantastic. Now it is this this strategy is more straightforward than if we're trying to find the length of one of the legs. In this case, we're looking for one of the legs. We see our right angle. We go opposite the right angle to find our hypotenuse. That is, our hypotenuse equals 35 here. That's a C. We can label the other ones as A or B as needed. Now we're working again with the Pythagorean theorem. So A squared plus B squared equals C squared. If we want, we can rearrange it right here. Otherwise, we could substitute in first and then rearrange. Let's try rearranging it first here. So if we're looking, if our unknown is A, then we want A squared to be on its own. If A squared if we're trying to isolate A squared, that means we need to move this B squared over. That means we're subtracting B squared from both the left side and the right side. So let's try that. We'll use a different color here. Minus B squared, leaving us with, on the left-hand side, just our A squared. On the right-hand side, C squared minus B squared. Fantastic. Now we can substitute in. So we know our value for C. And maybe I should label this sub in C equals 35. And B equals 8.4. Fantastic. So we're working with A squared equals 35 squared minus 8.4 squared. You can use a calculator for this here. We're working with 35 squared. That brings us, 35 squared is 1,225. And 8.4 squared, 70.56, minus 70.56. We're still working here. I know I ran out of space, but I'm hoping you didn't realize that my writing's a little bit larger. 1,225 minus 70.56. We're working with 1,154.44. Okay, that's great, but that's not what we're looking for, right? We need to square root both sides. A squared will square root that, leaving us with A equals the square root of 1,154.44. So A is approximately 33 point, and what were we rounding to? The nearest tenth. So it's actually 34.0. 34.0. So therefore, A is approximately equal to 34.0. You can see there is that extra step right off the start here. We're not trying to find the hypotenuse, but you should be able to handle something like that.